Oh, he said you wanted to record. Pressing the wrong button. So I hope you guys, your notes are up to date. Huh? Because remember, you use your notebook for revision. Hmm? Now, Sarah, you have let's start with
Yes.
metals. Metals. Let's start with metals. Let's start with we'll just start. I'm going to divide them into two. Huh? I'm going to look at physical. You need to know the difference between physical and the chemical properties. Huh? So let's look at the physical properties of metals. Physical properties of metals. Number one, the obvious one. Metals are solids. All metals are solids at room temperature, except what? Those doing physics.
Mercury, isn't it?
Except mercury is the only metal which is liquid at room temperature. Except mercury, which is the only metal that is liquid at room temperature. You can write that down. Except mercury, which is the only metal that is liquid at room temperature. Clear? The rest, solids at room temperature. Now are we together?
Mm-hmm.
Metals are good conductors of electricity. That's not a chemical property. Yeah, we need to know what are chemical properties, what are physical. That's a physical property. Clear? So this is under physical property, what I'm giving you. Metals are good conductors of electricity. In general, metals are good conductor of electricity. What's the best conductor of electricity for interest sake? Among the metals, what's the best conductor of electricity?
Silver.
Silver. So why do we use copper? Because copper is less expensive. Huh? Your zesta or whatever, they use copper. Clear? Silver followed by copper. Silver is the best conductor of electricity, followed by copper. Clear? Metals are good conductors of heat. In general, metals are good. It's very late like this. Metals are very good conductors of heat, unless they're blocked out. Metals are very good conductors of heat. Clear? Next point, metals are shiny. Metals are shiny in appearance. Clear? Are we together? Metals have high density. Generally, metals have got high densities. High density. Metals are malleable. What does that mean? Malleability. What does that mean? Malleable. Malleable. You guys. What does malleable mean? Kuda? Malleable. Laura, what does malleable? If I'm saying a metal is malleable, what am I talking about?
It can be turned into a shape or something without breaking.
It can be turned into
A shape without breaking or cracking.
Okay, it can easily be turned into a shape, turned into any form without breaking. Okay, I agree. Now, metals are ductile. What does that mean? Ductile. Ductile. They can be hammered into a wire. They can be hammered. Ductile. So now let's look at non-metals. So those are the physical properties of metals. Let's look at the physical properties of non-metals. Oh, sorry, we left one. Metals are sonorous. What does sonorous mean? You're doing English.
Sound.
Yes, they produce sound when you hit them. Sonorous means they produce
Metals
sound.
are what?
Sonorous. It means they produce sound when you hit them. Metals are sonorous. It means they produce sound when you hit them. Clear? For non-metals, you write the opposite of everything you've said. Huh? So number one, property. Let's look at physical properties of non-metals. Physical properties of non-metals. Most non-metals are gases.
Pardon?
Most non-metals are gases, and a few are liquids at room temperature. Most non-metals are gases, and a few are liquids at room temperature. Oh, can you go back? I left, sorry about that. On your table on metals, I left another physical properties. Metals generally have high boiling points. Metals generally have high boiling points. And metals also have got high. So melting point and boiling points are not same points, they're different points. Metals generally have high boiling points. Metals generally have high melting points. Clear? Is that making sense? Are we together? I think someone's network is having issues.
High boiling and melting points.
Is that your network?
They have high boiling and
I said high boiling
melting
points.
points, right?
I said high melting point is a different point. Yes. Clear? Under physical properties. So now let's go on to non-metals. We talked about them being gases, most of them, and a few liquids at room temperature. They are poor conductors of electricity. Non-metals are poor conductors of electricity. Clear? Non-metals are poor conductors of electricity. Non-metals are also poor conductors of heat. This is good for physics and computer and chemistry. Non-metals are poor conductors of heat. What about their appearance? Are they shiny like metals? What can you say about non-metals? They are dour in appearance. Yes, dour in appearance. They have low density. The non-metals have low densities. They are brittle and non-sonorous.
Wait, after dull looking, what did you say?
Low density. Did you write that down?
Sorry?
Low density. Did you write the low density?
I have no, yeah.
Did you write the low density?
Yeah, and then brittle.
Hmm?
And then you said brittle.
Your question here. Okay. I want to take a period. Yes, I said brittle, which means they easily break. and non-sonorous. There's something I want to do here. I want to take your periodic table. Do you have your periodic tables with you? I'm going to do something here that I haven't done here, so that we help some of you to know from the periodic table where do we find metals locally. Let me get my periodic table. I saved it somewhere. The one that you use for exams, the one that I want to extract. Where did I save it? Okay, exams. Found it. Nova. Give you a chemistry. Periodic table. Extended. Okay, table. Found it. So I'm going to load the periodic table there. Then as we are going to discuss, oh, it's upside down. How do I make it? Is there a way to rotate this? It's not in the form that, anyway. You have your periodic tables there. So what I need to mention here from this periodic table, I'll simply use it as it is. This thing can't give me a way to rotate it. Anyway, these are all metals. Do you agree? Group 1, group 2, all metals in your periodic table. You just need to know that knowledge. Then these are known as transition metals. I'm sure you know that. This block here. So if you've got your periodic table there, or maybe a copy of your periodic, this part here is known as transition metals. We'll talk about them just now. Only this part here. We call them transition metals. Clear? Are we together? Are we there? Oh, we are lost somewhere. Transition metals. Then from this part here, this is metals here. Then I do like this here to metals. I want to show you this as I'm doing that. Because this is not a metal. Then like this, a metal like this, the metals, then like this. Oh, sorry. There's something that was distracting me. Like this here. Then of course the TS that is not there. These are your metals. The rest non-metals. You see what I've done? Clear? Did you see that on this part here? Aluminium. Then I went to this here. So it means these are not metals. Metals start from there going down. Clear? In the group 4 is a combination. We'll talk about that. Metals and non-metals. Are we together? In this group, this is not a metal. So metals we start from this. Clear? Aluminium. So like that. Is that making sense, Kuda? Those are the metals, in your periodic table. You can share this like that if you want. Clear? Are we together? So far. So far, so good. Now let's look at the general chemical properties of metals. General chemical properties of metals. General chemical properties of metals. What do you know about the chemical properties of metals? Metals give away electrons when they react. 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 To form what type of ions? Do they form negative or positive ions? if they are giving away electrons?
Positive ions.
To form positive ions, because they will have more positive, to form positive ions. To form positive ions. To form positive ions. Clear? To form positive ions. Then you write under that, you write that O group 1 metals give away 1 electron. Give away 1 electron to form an X plus ion. X simply stands for whatever, we may sodium plus, lithium plus. O group 2 metals give away 2 electrons when they react to form X2 plus ions. Then O group 3 metals give away 3 electrons to form 3 plus ions. Then you can write that transition metals have got various oxidation states. We'll look at them. Transition metals have got various oxidation states. Transition metals have got various oxidation states. Clear? Transition metals have got various oxidation states. Transition
group
met-
7 met
What
have
this?
what electrons?
O group 3 electrons give away 3 electrons. O group 3 metals give away 3 electrons to form X3 plus ions. Then I said transition metals have got various oxidation states. Is that clear? Happy?
Mhm.
Now, who can tell me what is the bonding in metals? What type of bonding is 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 in sodium? In potassium? What do you call that? You don't know that? Metals have got a metallic bonding. All metals have got a metallic bonding. Metallic bonding, which is a lattice structure, which is more like a 3D, lattice structure of positive and negative ions, which is more like a 3D lattice structure of positive and negative ions. Clear? The reason why it conducts electricity is the electrons can freely move. Clear? Because if I'm talking of a lattice structure here, we're saying those electrons can freely move. They're able to move, clear, within that lattice structure. Clear? So it is a lattice structure. But sometimes they say draw a metallic bonding here. all you're supposed to show is you're showing a combination of negative, positive ions, lattice structure, something like that. I'm sure you've seen that in your textbook. Huh? Because although it's like a 3D, clear. Goes on, you continue like that. Huh? Clear. We're talking of a lattice structure, 3D lattice structure of positive and negative ions. Are we together?
Yeah.
Now, next chemical property is that metals react with water, not all. Huh? Metals react with water. In brackets, either warm, cold, or steam. In brackets, either warm, cold, or steam. Either warm, cold, or steam. To form metal hydroxides, to form metal hydroxides, to form metal hydroxides and hydrogen gas, to form metal hydroxides and hydrogen gas. Clear? Is that clear?
Yeah.
NB, all group 1 metals react with cold water. All group 1 metals react with cold water at room temperature. All group 1 metals react with cold water at room temperature. Clear? Let's look at the general equation. Laila, you're there? The general equation.
Yes, sir.
The general equation for group 1. So you can write general equation for group 1 with water. So I'll use X representing a group 1 metal plus H2O will form a metal hydroxide plus hydrogen gas. So this X here you can just, so this is for group 1 reactions with water. You can replace that with lithium, with sodium, with potassium. See, clear? Balance, not balanced, because I've got 2 hydrogens there. I've got 1 oxygen, 1. So I've got 3 there. So let's put 2 here. If we put 2, we now need 2, which is balanced, 4 hydrogens, 2 oxygen. Clear? So that's the balance equation, but that's just a general equation. Clear? Are we together? In terms of chemistry. Then in terms of states, listen to me, this is a solid here, because I said the metal is a solid. Water is a liquid. But the hydroxide that is formed, it will be in water. So we write aqueous. It means it's dissolved in water. Clear? Because the hydroxide is dissolved in water, group 1 dies. Then this is a gas. Is that clear? Making sense?
Yeah.
So you can write NB, all group 1 hydroxides are soluble in water. All group 1 hydroxides are soluble in water. Next point, group 2 metals, group 2 metals reacts in a similar way, as group 2 react in a similar way with steam as group 1, but the reaction is slow. But the reactions are slow. Clear? But the reactions are slow. But the reactions are slow. Then I want to show you what they love in the exams, which you should remember. Magnesium, which is your group 2, reacts very slowly with water. Magnesium reacts very slowly with water. Magnesium reacts very slowly with water. So I want to write group 2 here. You can write group 2 reactions with water. Remember, we're simply specializing on reactions of metals with water. Group 2, so if it's group 2, I will also use X here, plus H2O. But the hydroxide now has got a different, because it's a group 2. It will be like this. Solid, liquid, aqueous, gas. For the 2 balance. Clear? So we said, so the magnesium that I'm talking about, the reaction is like this. I'm simply putting magnesium there. Then it will be magnesium hydroxide. Once you understand this, then life is going to be easy. Clear? Okay. I said very slow. Huh? However, write this down. Huh? Because they love this in exams here. However, magnesium reacts vigorously with steam. Magnesium reacts vigorously with steam to form magnesium. Is the only one that does that. To form, that's why I said it's very important. To form magnesium oxide and hydrogen. We don't form a hydroxide when it reacts with steam. So reaction with steam. Reaction with steam, okay, AM. Reaction with steam, so it's your magnesium. How do you know that it's steam in an exam? If they write liquid like this, it means it's water. If they write steam, what do you think they're writing? What form is steam? Is it liquid or gas?
Yeah.
It's G. The moment you see G in an exam like this, magnesium H2G, it means it's steam. Huh? They don't have to tell you, it means it's steam here. So it's no longer a hydroxide that is formed, it forms magnesium oxide. That's what I said. I said, however, magnesium reacts vigorously with steam to form magnesium hydroxide, magnesium oxide, sorry, plus oxygen. We don't form, is the only case where we don't form a hydroxide, we form an oxide. Clear? And it's actually balanced as it is. Clear? Are we together there? An oxide, and this oxide here is a solid white oxide. Clear? Forming a white oxide. Aluminium, very important this part here. Aluminium is an unusual metal. Aluminium is an unusual metal. Aluminium is an unusual.
What topic is it?
We are we are talking of metals and non-metals. I told you it's metals and non-metals topic.
Oh,
Yeah, under inorganic. Aluminium is an unusual metal because it is a reactive metal, yet it does not react with water. So always remember that aluminium does not react with what? With water. Clear? Remember that aluminium does not react with water, but it's a reactive metal. Why? Who can explain that? Laila, you have finished the syllabus there. Why is that aluminium cannot react with water? It's unusual because it's very reactive metal that does not react with water. Why? Why does aluminium not react with water? Yet it's reactive enough to react with water. Because once aluminium is exposed to air, its surface reacts with oxygen. To form a protective layer of aluminium oxide. Its surface, the moment it's exposed to air, its surface reacts with oxygen, clear, to form a protective layer of aluminium oxide, which is insoluble in water, clear. To form a protective layer of aluminium oxide, which is insoluble in water. To form a protective layer of aluminium oxide, which is insoluble in air. And I even gave you the question there. I'm sure you can see my whiteboard. Huh? Aluminium. Can you see my whiteboard?
Yes, sir.
Yeah.
Yeah, this is the aluminium oxide that I'm talking about. That's what I'm. A protective layer of aluminium oxide. So that it's insoluble in water. That's why we're saying it does not react with water. Are we together or not together?
Yeah.
We are talking of reactions of metals. Now, so group 2, we've looked at them. And generally for group 1 and group 2, I'm sure you know that the reactivity increase as we go down the group. We talked about that when we're doing groups. So we don't have to look at that for now. For now, we're just talking of metals in general. We're saying in general, when they react, they form metal hydroxides and release hydrogen gas. That's in general. But then we talked of an exception where we have magnesium reacting with steam, forming magnesium hydroxide. Magnesium oxide, sorry. Are we together? Or not together?
Yeah.
Now, my question is, which metals do not react besides the aluminum? Which metals do not react with water? From your learning, which metals do not react with water? Which metals do not react with water?
Copper. What does it? Copper, yeah.
He's saying copper. So what do others think?
Oh, yes, it does.
The others,
zinc.
Laura. Zinc.
Iron.
Iron, when you talked about the rusting, yes, the other day, when you said you don't even need the water or the oxygen close to iron, it forms, didn't we say it forms rust? Iron rust. Hmm? We talked about it yesterday.
Yeah.
Did you guys forget? So metals such as lead, copper, like what he said. Metals, you can write that, metals such as lead, copper, silver, and gold. Metals such as lead, copper, silver, and gold do not react with water at all. Whether it's steam, whether it's liquid, clear, do not react with water at all. Metals such as lead, copper, silver, and gold do not react with water at all. Are we together? Do not react with water at all.
Yeah.
Which leads me to something here that maybe you need to know also the reactivity series of metals. Let's look at it before we even continue. The reactivity, we just want to exhaust everything you need to know for a syllabus. Reactivity series of metals. So it's obvious group one.
There's also another heading.
Yes, reactivity series, yes, of metals. You need to know it. Huh? So we start with potassium. Huh? Of course, there's rubidium above that. Sodium, calcium, magnesium, aluminium, zinc, iron, lead, Pb, copper, then silver, gold. Yeah? So below this there is Ag, then gold is the lowest. Huh? So in this way, reactivity decreases. Clear? Decreases. So if I said lead, copper, these do not react with, it means all these react with water. But some like your iron, your zinc, whatever, I think the reactions will be very slow. I'm sure you understand. Clear? Are we together? Making sense?
Yes.
Or not making sense?
Makes sense.
So we said in general, metal plus
Wait,
water
so you
gives
said lead and what?
what? Question?
You
Lead,
said
Cu,
lead,
is there. After lead, there's
then
Cu, that's copper. Then there's Ag after copper, that's silver. Then there's Cu, sorry, did I say Cu or Au? That's an Au, yeah, that's a mistake. For gold, yeah? That's an Au there.
before gold or after gold?
Gold is the last one. This, because I didn't have space here. After copper, there is silver. Then lastly, gold.
Which one?
Fe, iron, lead, copper. After copper, immediately below copper, it's less reactive. There's silver, Ag. Then below Ag, there's Au, which is gold. That's what your table should look like. That making sense? Are we together there? Now let's look at reactions of metals, the next property. Metals react with acids. Metals react with acids. Metals react with acids to form salts and hydrogen gas. So in metal or an acid plus metal gives you a salt plus hydrogen. So the hydrogen gas. An acid plus a metal oxide, and the properties, general properties, gives you a salt plus water. Then thirdly, an acid plus a metal carbonate gives you three things: salt, H2O plus carbon dioxide. Write those general things, then we just look at examples. Clear? Are we together? Are you there? Oh, I've lost you.
Yes, sir.
So an example, I'll give an example for each one. I can have zinc plus hydrochloric acid. I form zinc, because zinc forms 2 plus. So zinc like this, plus zinc salt, zinc chloride, plus hydrogen goes like that, sorted. Then the one that I said, the metal oxide, can give you an example of sodium. I said metal oxide, okay. Yes, so let's have sodium oxide plus sulfuric acid. We form sodium sulfate plus water. Clear? Are we together? Talk about the rest later. Then carbonate, calcium carbonate plus nitric acid. Nitric acid, we covered that, but we'll cover that again. And the acid base. And so we form calcium nitrate. Calcium nitrate is 1. So we need 2 nitrates. What this is 2 plus carbon dioxide plus water. 3 things, because it's a carbonate. Clear? Are we together? Is that clear so far? This is just general.
Yes, sir.
We lost someone, one of you there. I'm not sure who we lost there. Maybe it's the network. I'm suspecting that it's the network. So, gentlemen, now So if I go back to your reactivity series, which is, I want to go back to this. Where is the reactivity series I gave? This one here. So you see, all these will react with acids, but there's some exceptions. So you can write that copper and below, copper, silver, gold, platinum do not react with dilute acids. Clear? So copper, anything below copper. So copper, silver, gold, and platinum, no reaction with dilute acids. Clear? Copper, silver, gold, platinum, no reaction with acids. So the only way where copper reacts is when I'm using copper oxide or copper hydroxide. Clear? Copper itself as a metal, it does not react with acids. Clear? Are we together? Copper and anything below copper. I said copper, silver, gold, platinum do not react with acids. Is that clear? Now, last subheading before we wind up for today is write displacement reactions of metals. Displacement reactions of metals. Displacement reactions of metals. Just like what we did in group 7 is true for metal. Displacement reactions of metals. Under that, quickly, write displacement reactions involve a metal. Displacement reactions involve a metal and a compound of a different metal and a compound of a different metal. In brackets, a more reactive metal would displace a less reactive metal from its compound. A more reactive metal would displace a less reactive metal from its compound. Are we together? So I want to give you an example here. So if we dip a magnesium ribbon in a solution of copper sulfate, follow me? We know that copper sulfate is below your, so it's less reactive. Huh? So what does that mean? It means the magnesium will displace what? The copper ions. Are we together? Because it's more, it's less. Is that making sense? Could that be? This copper sulfate, what color is copper sulfate? Copper 2U plus contributed to a blue what? Remember from last term? Blue color. So copper sulfate is blue, clear. So that means the blue color slowly disappears. Huh? What's happening is that this is a displacement reaction. I'll form magnesium sulfate plus copper. That making sense? Why? Because magnesium is high up there in the reactive than the copper. So it displaces. Is that making sense? Observation, the blue color fades and a colorless magnesium sulfate solution forms. The blue color of the copper sulfate fades and a colorless magnesium sulfate solution forms. Clear? What about the copper? What do you observe? What do you observe in that reaction? So first observation, the blue color, it's a very important reaction. the blue color fades as a colorless magnesium sulfate solution is formed. The next point is that, so by the way, I'm talking of aqueous here because it's in water. So it's deep blue, clear. Are we together? So even this here is aqueous, but it's colorless in water, clear? Now, what we are saying, so this is colorless, according to what we are saying. American, if you want the UK, you there. So are we together? Colorless. Then a brown copper coats on the surface. Brown copper coats on the surface of magnesium. A brown, so observation, second observation, brown copper coats on the surface of magnesium. Clear? Are we together? Making sense or not making sense? So now my question is, if I am to pick your reactivity series, which metals can displace copper sulfate from your reactivity series besides magnesium? Anything above what? Above copper, clear? Do you agree? Anything
sir.
above copper will displace that, which means your zinc, your iron will displace copper sulfate. So it's a good one in the experiment. Anything will displace. So which means if I was to write this here plus zinc, what I form is zinc sulfate plus copper. Clear? Now, my question to you now is, which compound, which metal can displace? Go and look at your periodic table. Which one, sorry, at your reactivity series, which one would displace magnesium sulfate? Which metal? Can this displace magnesium sulfate, the iron?
No.
Nope, because it's below. So we want things above, which means what? We are looking at calcium, we are looking at sodium, we are looking at potassium. So is that making sense? So if I was to react here, for example, with potassium, I expect to form potassium sulfate, synthesis group 1 like this, plus magnesium. Displacement reactions. Is that making sense?
Yes, sir.
Happy there. On the displacement reactions of metals. Let's wait there. We'll continue. And then from that, I hope everyone was your notes updated. We have lots of folks there. Maybe it's their network. It's time for what? For lunch. What does your timetable say?
For bio.
Time for
Physics.
some are saying bio, some are saying physics. Which timetable are you guys using? So it's bio is what? Isn't bio the last lesson, if I'm correct? Bio is the last lesson. Today is what? Thursday. Unless no, today is Tuesday. So it's physics. We switch to physics here.